ನನ್ನ ಹತ್ರ ಇಲ್ಲ ಇದು. Okay, I'll start with the numerical problems on gear drives. Okay, hope all of you are seeing the contents on the screen. Okay, the first problem is the velocity ratio of a gear drive is 2. Driving wheel has 16 teeth and runs at 160 rpm. Find the rpm and the number of teeth on the driven wheel. Okay, so okay. Driver and driven. Okay, so driver has 16 number of teeth and it rotates at 120 rpm, and driven teeth we have to calculate, and speed of the driven teeth we have to calculate. Okay, velocity ratio for simple gear train is given by sir class is record ಆಗ್ತಾ ಇರುತ್ತೆ sir. So simple gear train, we are having the formula N2 by N1 is T1 by T2. Yesterday we discussed in the class. Okay. So N2 is what? Speed of the driven gear, and N1 is speed of the driver gear, and T1 and T2 are the number of teeth on driver and driven gear. Okay. Just you substitute the value. N2 by N1 is given in the problem, that is 2. And T1 is given in the problem as 16. So our aim is to find out T2. T2 is just, it is 16 by 2, 80th. Okay. Next, we have to calculate the N2, speed of the driven wheel. You have to apply this formula. N2 by N1 equals to T1 by T2. N2 is, we don't know. N1 is given in the problem 120 rpm, and T1 is number of teeth on the driver wheel gear 16 and divided by 8. That is the number of teeth on the driven gear. So after substituting, you'll get the value as 240 rpm. Okay. Before solving the problem, just I'll remind the equation for gear drive, that is N2 by N1 equals to D1 by D2. Okay, equals to T1 by T2. Velocity ratio of simple gear train, and the formula you remember, N2 by N1 equals to D1 by D2 equals to T1 by T2. This is the formula used to find out the velocity ratio or diameter or number of the teeth on the driver gear or driven gear. N2 is speed of driven gear, N1 is speed of the driver gear, D1 is diameter of driver gear, D2 is diameter of driven gear, T1 is the number of teeth on the driver gear, and T2 is number of teeth on the driven gear. Okay, so this is the formula you have to remember to solve the numerical problem. Okay, so problem number 1, velocity ratio of gear train is 2. The driving wheel has 16 teeth and runs at the 120 rpm. So using this formula, N2 by N1 equals to T1 by T2. N2 by N1 is 2 and T1 is 16 divided by T2. First, we are going to find out number of teeth on the driven gear. It is 8 teeth. Next, once again you apply the same formula, N2 by N1 equals to T1 by T2. So N2 we don't know. N1 is 120 given in the problem, equals to 16 by 8. So you're getting N2 equals to 240 rpm. You remember the speed in case of a gear drive is inversely proportional to the diameter as well as your number of teeth. Okay. The second problem you see, okay, a simple gear train. Okay, gear train is, it is a structure which is consisting of more than 2 gears. We are having intermediate gear, that is also called as idler gear. A simple gear train consisting of 3 gears. The number of teeth on the driving gear, you see the first diagram. Okay, the first wheel, it is having 60 teeth on the driving gear, and on the idler, you remember idler and intermediate gear are same. So you have to show one idler gear in between driving gear and driven gear, and number of teeth on the idler gear is 40. Okay, so just you have to change the diagram according to the number of teeth. You see 60 is there, that's why you have to draw one circle. Next we are having 40, you have to draw small circle. And next after that we are having the driven gear is having 80 teeth. Like according to the number of teeth you have to draw the diagram. Okay, if the driving gear rotates at 1200 rpm, this one, so N1 is 1200 rpm. Find the speed of driven gear. That is N3 you have to find out. You call it as N1, N2 and N3. So our aim is to find out the velocity of third gear, that is driven gear, and also the velocity ratio. Velocity ratio means the ratio of speed of driven to driving, that is N3 by N1, and also sketch the arrangement of gear drive. Okay. First, you have to draw a tabular column. Given data, driving gear T1 is 60, N1 is 1200 rpm, T2 is 40. We don't know N2. Just keep as it is. Next, driven gear. Number of teeth on the driven gear is 80, and N3 is the speed we don't know. Okay, this is first step to solve the problem. Okay. Next, how to find out your N3. Okay. So as I said, in case of gear drive, the speed ratio is inversely proportional to number of teeth. So as teeth increases, speed decreases. As teeth decrease, speed increases, and vice versa. So our aim is to find out velocity ratio. Velocity ratio means always the speed of last gear to the speed of initial gear. That is called velocity ratio. N3 by N1 equals to T1 by T3, because N3 is inversely proportional to T3 and N1 is inversely proportional to T1. Like that you have to remember. Speed ratio is always inversely proportional to the ratio of teeth. N3 by N1 equals to T1 by T3. So in this problem, N3 we don't know. Just you keep N3. N1 speed of the driving gear is given 1200 rpm, and T1 number of teeth on the driving gear 60, and T3 is the number of teeth on the driven gear. So by substituting this value, we'll get the speed N3 by N1 is 0.75 in driven gear. Next, our aim is to calculate speed ratio. Speed ratio is N3 by N1. N3, just now we got it as 900 rpm, and N1 speed of driving gear is 1200 rpm. So 900 by 1200 is the speed ratio, or it is 3:4. That is N3 by N1 is 0.75. That is the speed ratio in case of simple gear train. We are having one idler gear in the gear arrangement. Okay. Next problem you see, problem number 3. Okay. So first you read the problem. A simple gear train consisting of 4 gears of 30, 40, 50 and 60 teeth respectively. Okay, so you see the number of teeth are in arranging or increasing order. That's why you have to draw 4 circles in the increasing order. So if it is there a variation, you have to draw according to the number of teeth. That is called as gear arrangement. Okay, here a simple gear train means the gear system having more than 2 gears, that is called as gear train. Here 2 intermediate gears, they are also called as idler gears. Okay, a simpler gear train consisting of 4 gears having 30 teeth, 40 teeth, 50 teeth and 60 teeth respectively. And you have to show inside the circle, you have to show one more circle, that is called a shaft, because the gear is running in between the shaft. So we are having 4 gears. So next you have to write the given data. T1 is 30 and N1 is 600 rpm. They are given only the number of teeth of all the gears and speed of the first gear, that is 600 rpm. T2 is 40, T3 is 50, T4 is 60, and we don't know the speed of all the gears. We know only the speed of first gear, that is 600 rpm. And our aim is to determine the speed of last gear as well as direction of rotation. So direction of rotation is most important. The gear 1 drives gear 2. One is in clockwise and one is in anti-clockwise. Once again, you have to show these two gears are in opposite direction. One is in anti-clockwise direction and next one is in clockwise direction. And last gear is opposite to that of third gear. Third gear rotates in clockwise direction and fourth gear rotates in anti-clockwise direction. That's why the arrangement of gears and as well as the direction of rotation also important. You have to show the two gears in opposite direction. So gear 1 clockwise, gear 2 anti-clockwise, gear 3 clockwise, and gear 4 anti-clockwise. Like that, you have to show all the gears in opposite direction. Okay. Next, how to find out the velocity ratio? As I said, velocity ratio is always given by the speed of the last gear divided by speed of the first gear. That is called as the velocity ratio. That is the speed of last gear means it is called as driven gear, and this is called as driving gear. And whatever the gears exist in between, those are called as intermediate gears. Okay, speed ratio is always speed of last gear to the speed of first gear, and also it is inversely proportional to number of teeth. That is T1 divided by T4. You have to write N4 by N1 equals to T1 by T4. Okay, that is inversely proportional. Okay, now in this case, what are the given data? Okay, N4 we don't know. N1 is given how much? N1 is 600 RPM. T1 and T4 are given. T1 is 30 and divided by 60. So N4 divided by N1. Okay, here in this case, no need to find out the speed of the intermediate gear. Okay, so directly we can calculate speed in the last gear. Okay, so N4 by speed of first gear is 600. T1 number of teeth on the first gear is 30. Number of teeth on the last gear is 60. So after simplification, we'll get the velocity in the last gear as 300 RPM, and also which direction? It is in anti-clockwise direction. You have to show the first gear always with clockwise direction, and second gear in anti-clockwise, and third gear in clockwise, and gear fourth in anti-clockwise direction. So the direction of fourth gear is in anti-clockwise. That's why that is called as direction, and speed is 300 RPM. You see, the speed of gear 1 is 600 RPM, and we are getting the speed of the last gear as 300 RPM. As the number of teeth increases, the speed of the gear drive decreases. Okay, as the number of teeth decreases, the speed increases. As I said, the velocity ratio is always inversely proportional to your the number of teeth. Okay. Okay, now another problem. Okay, here one more extra thing is there, that is value of gear train. I'll explain. Okay, first you see the problem. Okay, a simple gear train consists of 4 gears A, B, C, D having 20 teeth, 40 teeth, 60 teeth, and 70 teeth respectively. Okay, gear A you have to show in clockwise direction, gear B in anti-clockwise direction, gear C in the clockwise direction, and gear D in anti-clockwise direction. Okay, this is the first arrangement of gear. The gear is mounted on the driving shaft. Gear A is driver shaft and gear D is your driven shaft. You remember, in first gear always gives your driving gear, and last gear always gives your driven gear. And whatever the gears we are having in between A and D are known as intermediate gears or idler gears. Okay. If gear A rotates at 500 RPM in clockwise direction, so they are given the number of teeth of all the gears, 20, 40, 60, and 70 respectively. And you have to show the direction of gear drive. Number of speed of gear A is 500 RPM and in clockwise direction, clearly given in the problem. Calculate the speed and direction of gear D. That is last gear you have to calculate. What is the speed? ND. And the direction, anyhow it is you are getting in anti-clockwise direction. Then one more is there, train value of gear train. Okay, speed and direction of intermediate gears. In the previous problems we found out only the speed of the last gear, but in this problem they asked how to find out the speed of intermediate gears. Okay, sketch the arrangement of gear train using simple circles. Okay, first step is you have to draw 4 circle in increasing order, because the number of teeth are increasing order. TA is 20, TB is 40, TC is 60, and TD is 70. That is number of teeth are in increasing order. First one in clockwise direction, second ACW, third CW, and fourth one is ACW, that is in anti-clockwise direction. Okay, next how to find out your velocity ratio. Okay, so because here the idler gears are given, you can apply the velocity ratio formula. That is NB divided by NA equals to TA by TB. Always you have to take inversely proportional. NB divided by NA equals to TA divided by TB. NB we don't know, so put as it is. NA, speed of first gear, is 500. TA is number of teeth, that is 20. TB is number of teeth on B is 40. So after substituting this one, the speed of second gear, that is gear B, is 250 RPM. Just you apply the simple formula. NB divided by NA equals to TA by TB. We know all the values except NB, speed of second drive. So NB divided by NA is 500. TA is 20, number of teeth, divided by 40. So NB we are getting it as 250 RPM in anti-clockwise direction. First is in clockwise, obviously second is in anti-clockwise direction. Okay, now you have to take the gears B and C. How to write the formula? NC divided by NB. Okay, third divided by second. NC by NB equals to TB by TC, because it is speed is inversely proportional to number of teeth. NC divided by NB equals to TB by TC. So NC divided by NB is how much? That is speed of second gear, 250 RPM we got. TB is your 40, number of teeth on gear B 40, and number of teeth on gear C is 60. So after simplification, we are getting the speed as 166.67 RPM. You observe that the speed is gradually decreasing as the number of teeth is increasing. You remember? So as number of teeth will be more, the speed will be less. Okay, like that here, number of teeth increasing, so the speed is decreasing. Starting we are having a 500 RPM, next we got 250 RPM, next we got 166 RPM, and finally we'll get the less RPM for the fourth gear drive, that is your driven gear. Like that, now you have to apply between C and D. Okay, how to write the velocity ratio? ND divided by NC, always last by first, that is ND divided by NC equals to TC by TD. Okay, ND by NC equals to TC by TD. So ND divided by just now we calculated NC as 166.7 equals to 60. Number of teeth on TC is 60 divided by 70. So as I said, you'll get still less than that of NC. We are getting around 143 RPM in the anti-clockwise direction. Okay. Next, one more, just you apply a simple formula, you'll get the speed. Next, you have to find out one more they ask, that is called as train value of gate train. Train value is always given by the reciprocal of speed or velocity ratio. You remember, this is standard formula of train value, reciprocal of velocity ratio, that is 1 divided by speed ratio. But we don't know speed ratio. What is speed ratio? ND divided by NA equals to TA divided by TD. Just we calculated all the speeds, but we have not calculated the overall velocity ratio. How to find out overall velocity ratio means ND divided by NA equals to TA divided by TD. Very simple formula. So you have to apply, first you have to find out speed ratio. ND divided by NA equals to TA divided by TD, or ND divided by NA equals to TA by TD. They are given in the formula 20 divided by 70. So we are getting the velocity ratio as 3. Okay. So we are getting the velocity ratio as 20 divided by 70. Okay, that is a speed ratio. But formula for train value is 1 divided by speed ratio. That is 1 divided by 3.5. This is 2 by 7 is nothing but 3.5. Okay, so 1 divided by speed ratio, you are getting it as sorry, so 20 by 70 you have to calculate, you are getting it as 0.285. So same thing here, you have to take, so 1 divided by 0.285. So you're getting the train value as 3.5. Just you remember, the train value formula is the reciprocal of your speed ratio. ND divided by NA equals to TA divided by TD. Whatever the value you are getting, just you have to take the reciprocal. That gives your the train value, that is called train value of gear train. Okay, whatever I discussed till now, it was the simple gear train. Now I'll discuss one important problem related to your compound gear train. Okay, compound gear train, as I said, in the compound gear train, so a single shaft carries more than 2 gears. Okay, now you see the structure, whatever you are seeing on the screen, it is of compound gear train. First, I'll explain the problem. Okay, a gear train consisting of 4 gears: gear A, gear B, gear C, and gear D. Okay, so having 20, 25, 50, and 75 teeth respectively. This one 25 teeth, that is TA 25, TB, sorry, TA is 20, TB is 25, TC is 50, and TD is 75. These are the number of teeth on the compound gear train. Okay. Next, gear A meshes with gear A. You see the gear A meshes with C. Okay, you have to show meshing part. Okay. On the other hand, B is a compound gear which is meshes with C. Okay, so whenever they are given like that, B and C are the intermediate gears, and these are called as compound gear. You have to show so in the two circles only, you don't show separately. You have to show separately in case of simple gear train, but whenever it comes to compound gear train, you have to show in so one center point. Okay, the gear B is of 25 teeth and gear C is of 50 teeth. Like that, you have to draw two circles. And one more important thing is direction of rotation. The gear A rotates in clockwise direction. Gear B and gear C both rotates in the opposite direction. They are in anti-clockwise direction. And finally, gear D is in a clockwise direction. Okay, don't show separately. Here, intermediate gears, they rotate in the same direction and opposite to that of gear drive A. That's why you have to show first one is in clockwise direction, and second, this gears B and gear C are in opposite direction. They are in anti-clockwise direction, and gear D in clockwise direction. They're like that. You have to show the sketch. Okay, and you have to show in such a way that the gear A meshes with the gear C. You see the diagram. Gear B and gear D are meshes with each other. Like that, you have to show the diagram. Okay, so the sketching is most important in case of gear drive. So you have to show circles according to the number of teeth and according to the meshing. Okay, this is that is a diagram of compound gear train is important. Okay, next, whatever given data, gear A, first you write the gear A, number of teeth on gear A is 20 and NA is 300 rpm. Okay, next, gear B, number of teeth on gear B is 25. Okay, and next, gear C, number of teeth on gear C is 50. That's why we have drawn in increasing order. And last one is 75. We don't know the speed of the last gear. So how to find out? they asked if A has speed of 300 rpm, what is the speed of D? Okay, so our aim is to find out the speed of the last gear. Okay, what is the speed of driven gear? Okay, next, as we discussed in the previous class, so the velocity ratio in case of compound gear train differs. Okay, that is speed of last gear divided by speed of first gear equals to the product of teeth on the driver divided by product of teeth on the driven. So this theoretical concept I explained in the previous class. Okay, just you remember, in case of compound gear train, the speed of last one divided by speed of first one equals to the product of teeth on the driver. That is, driver means what? A and B. Okay, so here these are the driver. Okay, because gear A drives gear C, gear B drives gear D. So driver gears are A and C. Sorry, A and B, and driven gears are C and D. Okay, A and B are driver gears. Driven gears are C and D. So ND divided by NA equals to TA into TB. After driving, so after drawing the sketch, you have to analyze what are the driving gears and what are the driven gears. So because gear A drives gear C, these and driver gear B drives gear D. Hence, A and B are your driving gears. C and D are your driven gears. Okay. Because A drives C and B drives D. So C and D are driven gears, A and B are driving gears. So ND by NA equals to TA into TB divided by TC into TD. ND by NA, our aim is to find out ND by NA, and number of T they are given, TA into TB. That is 20 into 25 number of teeth divided by TC into TD. That is 50 into 75. After simplifying, we are getting the speed as 40 rpm. Okay, NA is given, how much? NA is given in the problem as 300 rpm. So after substituting ND divided by 300 equals to 20 into 25 divided by 50 into 75. After substituting this value, we are getting the speed in the last gear as 40 rpm. You remember, the speed decreases as the number of teeth increase, because we are having 75 teeth on the last gear. So due to this high number of the teeth, the speed of the last gear decreases. So the speed of the last gear is 40 rpm. Okay, next, 4. Okay, it's very simple problem. So only the sketching is important. You have to remember how to calculate the number of teeth on the last gear. ND by NA equals to TA into TB divided by TC into TD. Okay, by substituting all the values, we'll get speed of the last gear as 40 rpm. Okay. Now I'll discuss one more problem, important problem. Such kind of the problems they'll ask in the exam. Okay, once again, whatever I'm explaining, it is of compound gear train. So before drawing the circles, you have to read the problem carefully. Okay, this problem, a compound gear train consisting of 4 gears P, Q, R and S, having 20 teeth, 40 teeth, 60 teeth and 80 teeth respectively. They are in increasing order, 20, 40, 60 and 80 respectively. And one more important thing they have given, the gear P is connected to is key to driving shaft, and gear S is to the driven shaft. Okay, Q and R are compound gears. They are given clearly that Q and R are compound gears. Okay, so as I said, compound gears you have to show in between driving gear and driven gear. So here in this problem, P is driving gear, S is driven gear, Q and R are the compound gear, and they are rotating in the same direction and they are connected to the same shaft. Okay, so first you have to show the diagram, and next they are given Q meshing with P. You see, remember Q, whatever the gear Q, meshes with gear P, and R, this outer circle, meshes with gear S. So they are giving clearly in the problem. According to the statement, you have to draw the gear train sketches. So first is driving gear and last one is driven gear. In between, we are having the compound gears. Okay, so gear P meshes with your gear Q. That's why first you have to show in clockwise direction, and next one is anti-clockwise direction, and clearly they are given Q meshing with P. Okay, and on the other hand, the R, gear R, meshes with gear S. So according to the meshing, you have to draw the circles. First, the arrangement of gear drive is most important. Don't make any mistake in drawing the circles. Okay, then once you understand how to draw the circle, then you have to write the given data. Okay, so first you make on tabular column, uh, write 4 gears P, Q, R and S. After that, whatever given data, TP, number of teeth on the gear P, 20, number of teeth on Q, 40, okay, number of teeth on R, that is 60, and number of teeth on S is 80, and speed of gear 1 is given 150 rpm, and last gear we need to calculate. Okay, as I said, so once again same formula you have to apply for compound gear train. Velocity ratio, that is ns divided by na. Speed of the last gear is s divided by speed of first gear is p, equals to the product of teeth on the driver. Now you analyze what are the driver gear and what are the driven gears. Okay, here gear P drives gear Q. Okay, and gear R drives gear S. You see the arrangement. P is driving gear, Q is driven gear, R is driving gear, and S is driven gears. So in this sketch, 2 are driving gear and 2 are driven gear. The gears P and R are your driving gear. That's why analyzing the driving and driven are most important. Okay, because gear P drives gear Q. One is driver and one is driven. And you see the circles of R and S. Gear R drives gear S. So in this case, 2 are driving gears. The gear P and gear gear R are the driving gear, and driven gears are uh, Q and S. Okay, Q and S are driven gears. Okay, so driving gear are P and R, and driven gears are Q and S. Now you write the formula for the velocity ratio. That is, velocity ratio is given by the speed of last gear, that is ns divided by np. You have to take last by first, equals to the number of teeth on the driving gear. Driving gear is tp into tr. Okay, divided by number of teeth on the driven gear, that is q and s, divided by tq into ts. Okay, just you substitute all the values. So ns we don't know, np is given in the problem 150. Okay, equals to number of teeth given in the problem. So after substituting the value, we are getting the speed as 56.25 rpm. Okay, so first step is you have to read the problem statement carefully, write the sketch accordingly, whether it is a simple gear train or it is a compound gear train. Okay, and next you have to show the arrow mark. Always you have to start driving gear in the clockwise direction and driven gear in the anti-clockwise direction. So first, based upon this one only, you'll get everything. That's why drawing the circle is most important in gear drives. Okay, so ns divided by np equals to uh, tp into tr divided by tq into ts. So substituting all the values, we are getting the speed of last gear as 56.25 rpm. Okay, now I'll discuss the last problem. Okay, you see the last problem. Okay. So you remember we are going to study the next chapter that is called as machine tools. We are going to discuss lathe machine, etc. In the lathe machine, these gears are used. I think you might have seen in watches where spur gear is used. Okay, spur gear means the having the straight tooth structure. Okay, whatever just you go is whenever you open your watch, you'll observe the gear structure. Gear is power transmission device. We are having some small circle structure in the watch, that is your spur gear. Okay, next you see the problem. Okay, now last problem uh, is the illustrated is a figure shows the gear drive arrangement used in a machine tool. A motor drives the gear at 950 rpm. Gears B, C, D are fixed to the parallel shaft rotating together. The number of teeth on each gear is given below. Determine the speed of the last gear F, which is mounted on the output shaft. Okay, so here the number of teeth on the different gear drives are given. According to the number of teeth, you have to draw the circles. Okay, TA is 20, TB is 50. Okay, so they have given the sketch. Sometimes they give the sketch also. Directly they have given the sketch in the problem, and number of teeth also they are given. Suppose if they are not giving the sketch, you have to draw the sketch. But in this problem, they are given directly the number of teeth as as well as the sketching of the gear arrangement. Using this one, you have to calculate. TA is 20, TB is 50, TC is 25, and TD is 75, T is 25, and TF is 65. So everything they have given, your aim is to find out the speed of the last gear. They are given only the number of teeth. So your aim is to find out what is the speed of the last gear. Okay. So you have to show the sketches, and uh, once again you have to use the formula to find out the velocity ratio as well as the speed of the last gear. Okay, velocity ratio, always you have to take the speed of the last gear to the speed of first gear, that is nf divided by na equals to the product of driver teeth. Once again you see the diagram carefully. So can you observe what are the driving gear? So you see driving gears are um, TA. TA is your driving, TC is your driving, and TE is your driving, because these three gears drives the other gears. So TA, TC, and TE are your driving gears, because driver A drives B, C drives D, E drives F. So from the diagram, it is very clear that gear drives A, C, and E are the driver gears. On the other hand, B, D, and F are your driven gears, because A drives B. A is driver, B is driven. C drives D. C is driver, D is driven. Next, E drives F. E is driver and F is driven. So, three driving gears and three driven gears. A, C, and E are driving gears. B, D, and F are your driven gears. So, according to the formula, the speed of last gear to the speed of first gear equals to the product of teeth on the driving gear, that is TA into TC into TE divided by TB into TD into TF. Okay, so first you analyze the diagram, just you write the formula. NF divided by NA equals to TA into TC into TE divided by TB into TD into TF. Okay, so once you write the formula, just you substitute the values given in the problem. Okay, TA is 20, TC is 25, TE is 25 divided by TB, everything they have given. Speed of the last gear, and one more thing, here NA is given 950 RPM. Obviously, the speed of the last gear will be less. Okay, so you're getting around 48.7 or 49 rpm. Okay, so this is how to solve the numerical problems on gear drives. Okay. Alfred, Anthony, Alfred, Alfred, Kirtanar,
Yes, sir.
understood the problems?
Yes, sir, I understood.
All the problems? Okay.
Yes, sir, I have to solve so I'll get to know more.
Okay. No, at least you understood the concepts, right? How to take, how to
Ah,
drive.
yes, yes, sir.
Okay, okay. Just I have posted all the problems in your Google Classroom. Whatever I discussed today, I have posted all the problems. Okay. So just you go
Okay, sir.
through, you refer the course material and you try to solve the problem. Okay.
Yes, sir.
Mm. Aditya, Aditya Patil, Aditya Patil. Am I audible? Aditya. Okay, guys, this completes your module 4. Okay, so completion of all theoretical concepts and problematic concepts of module 4. Okay, and module 5 I'll start in the next class. Okay, very simple module. Module 5 is very easy. Okay, compared to all the modules. Only we are going to do the machining process, that is normal machining process and advanced machining process. Okay, we don't have any numericals in module 5. We are having the numerical problems only in module 2, 1 and 4. Okay, so in next module, module 5 only, you have to explain all the machining process with the sketches. Okay, thanks for joining the class. Okay, I'll stop the class now. Okay, we'll discuss the module 5 in the next class. Okay, thank you one and